Okay, so we are going to draw the first molecule, CH4. You guys probably are smart enough to tell me right off the bat what it's going to be. What is it? Just tell me. CH4. We're going to do CH4. I have them listed here. It's the same thing as on your Google Doc. Ooh, who said nonpolar with H's all the way around? It's going to be what shape? Very good, class. Proud of you guys. It's going to be tetrahedral. Okay? Tetrahedral, and I like to draw the wedges and the dash because it shows you a three-dimensional shape. So it is tetrahedral, and it is therefore nonpolar. Okay? Nonpolar. All right. So now in the next one, it says CH2F2. So we did that. Did that already. CH2F2. Okay? CH2F2. Well, all I have to do is get rid of this and get rid of that. And put a fluorine there and a fluorine there, right? And then I got to put my dots. Make sure it has all my dots. Okay, you getting that, Amber? No? Okay, Amber, here we go. CH2F2. How many valence electrons does carbon have? Has 4. How many valence electrons does 2 hydrogens have? 2. How many valence electrons does 2 fluorines have? 14. Amber, what's 4 plus 2 plus 14? 20. Okay? So I'm going to use what I know. Carbon is always in the middle. Carbon's always in the middle, Amber. It's a rule. Period. Carbon's always in the middle. Period. Hydrogens are always on the outside. Period. Never change. Repeat that back to me. Carbon is. Hydrogen is always outside. Okay, Amber. The formula says we have 2 hydrogens and 2 fluorines, right? Okay, start right away connecting. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Done. Now, guess what? Carbon now has 4. This fluorine has 4. And this fluorine has, I'm sorry, this fluorine has 8. Carbon has 8. This fluorine has 8. Everybody's happy. I'm going to draw this three-dimensionally with the dashes and the wedges. I mean, yeah, I usually just draw it like that. Now, look at it. Polar or nonpolar? Which side is more electronegative? So where would I point the arrow? Point with your hand. Yep, that's right. I would point it to be this way, polar. It's not nonpolar. It is now polar. But watch this. Are you ready to be totally have your universe destroyed? Are you ready to feel lied to and betrayed? Good. So I'm going to switch this hydrogen with this fluorine, and it's going to detonate y'all's universe. But if you guys are savvy, it really shouldn't. Interesting. So if I put the fluorine here and a hydrogen here, then is it still polar or nonpolar? I want you all to think three-dimensionally. Okay? I want you all to think three-dimensionally. What? Rotating? Noah, that's a strong possibility. Well, let's see here. All right. I'm going to put 2 hydrogens and 2 chlorines on here. The greens represent the fluorines, and the yellows represent the hydrogens. Here we go. Okay, Summer, this was the first way we drew it. This is the way we drew it the first time right here, didn't we? Yeah? Okay, are you ready? I'm going to spin it. Did I change the molecule at all? No. Did I make it nonpolar all of a sudden? No, I did not. It's the same thing. The same thing. Just because it faces you doesn't mean it's nonpolar. It's the same molecule. Polar, 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 polar. Every way you spin it, it's polar. This is still polar. Well, the arrow, I guess, would come straight off the page at your face. You see that, Jeremiah? Okay. So, all right. And then moving on to NH3 and H2O. I know you guys have drawn NH3 and H2O 100,000 times, but there is a rule that I want you to learn for the rest of your life. I want you to be able to tell your grandchildren this. Okay, so we did that one. We're going to now do NH3 and H2O. NH3, you guys have drawn this 100 times. What is it? What shape? Hello? You guys have drawn it 1,000 times. You can just tell me right off the bat. What is the name of the shape that it makes? Trigonal what? No, it's not planar. It's a three-dimensional shape that sits up in a point. It's a pyramid. You guys are on the YouTubes shouting out wrong answers. Trigonal pyramid, and this is bent. Okay, we're going to draw an arrow to the polar bear. Where's the polar bear point for this one? Yep. So we draw it polarity up, or electronegative molecule. So this one bent up. Okay. I'm going to simplify the universe for you all. Are you ready to have the universe simplified? Okay. Look here, folks. Anytime you draw a bent molecule or a pyramid molecule, it's permanently polar, period. All, not some, not a few, all bent and pyramids are permanently polar, period. Because that's the way they're shaped, right, Jerron? Okay? So, all the time, all of them, total, every one, everywhere, all around, all the time, 24, 365, 7, 12 months, every day, all night, doesn't sleep, all the time. Pyramids, polar, bent, and pyramids are polar, period. All bent and pyramids are permanently polar. All of them in the universe are polar. That's it. The universe. Okay? Anytime you have a trigonal pyramid and anytime you have a bent molecule, it is polar. Period. It's polar. Got it? Okay. Now, can tetrahedrals maybe change? Tetrahedrals can be different. Can trigonal planars be different? Okay. Can linear be different? Those can be different. Bent and pyramids cannot be different. Those are polar. I don't care what you put on here. Okay. I don't care what you put on the molecule. They are polar. If it wasn't like this, we wouldn't be here. If this thing was not polar, water was not polar, we would not have any oceans. We wouldn't be here. There'd be no life. All right. Any questions? So has everybody learned that? Hopefully.